Hello, I'm Pete Verdone. Um, going to be making some videos. I promised recently that I would start getting in the habit of more of this type of thing, and a current project lends itself pretty good to that. Um, if you don't know, I've been making various frame fixture, uh, what would it be called, a breadboard style bicycle frame fixture for the past several years. Got several designs. The Cyberdyne, the Skynet, and the Whopper. Those are three different fixtures that do the same thing, you know, hold parts together to weld together to make a bicycle frame. They do the same things, but they do it in different ways, but all using a breadboard type system. And I'm I've recently taken I'm looking at redesigning the Skynet, doing the Skynet 2, and I put a little work into that. But I figured I could do a video series of my perspective on frame fixtures. What are we trying to do? What are good ways of doing things? What are less good ways or just plain bad ways of doing things? And just kind of chat a bit about this kind of thing. So I figured that would be this video, let's say, will be a sort of a precursor to talking about the Cyberdyne. That'll be another video. And then I'll do a Skynet and a Whopper video. And then we'll do a Skynet 2 video where I'll talk about what I expect the Skynet 2 to do that's different from these others, or what problems it solves or does better. It's generally an elaboration on the Skynet fixture. I'm currently using the Cyberdyne. That was made in real life and has been getting use. And while it's fairly good, better than anything else I've used, it has problems. We never hit a home run at the first at bat, and I need to fix some problems. And I figured, why not just make a whole new fixture or something like that. So first, let's talk about what we're doing with a bicycle frame fixture. Um, Let me pull up our bike CAD. Okay, this is the recent M2 F2 that I did. Pretty cool all-road performance type bike. Probably put it into the 75%, no, not 75, maybe 70% off-road, 30% on-road type of bike. Long, fast ride type of bike. Mostly dirt. You can get on pavement too. Um, but, a frame fixture is sort of like what happens after we get to this point. We've defined the bike virtually, and we've figured out what shape it should take in general. Um, let's see. I should have done this a while back. Let's open up the we're getting this in real time. Although I did try to prepare, I forgot to just plain open up the actual bike. We're going through my files. You get to see the bloody mess that everything is. Let's go into the frame, fork, and handlebar assembly type thing. Hopefully there won't be redundant parts there. And I'm going to maximize the screen. This will take a while. But before we get to the 3D file, we have to do the 2D file. And I can talk about geometry on a whole separate post. But when we make a frame fixture, we need to hold certain elements in place so it produces the exact results we're after. Welding distortion happens. Oh, good. Okay. we got an even better thing. So we're going to have to pause. I'm still learning how to navigate all this stuff. So let's pause. Okay, we're back. So I'm working on my system for how to do this stuff. I'm doing it on the fly. Okay, so we want to be very precise. We want to get the results we intend. That's always the goal. And we want a certain amount of precision. You know, this is bicycle production is fairly rudimentary metal craft, basic weldments. We want certain qualities. We want the wheels to be in plane and preferably in plane with the cranks, as well as the saddle. We want the handlebars centered. We want a lot of things to be aligned fairly well. We can handle a little bit of misalignment in terms of the angles, but we don't want that. We want to get what we want to get. So we're trying to get a certain level of precision. A problem happens when we try to be very, 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 very precise to a point where welding distortion is already going to completely destroy that. And there's ways of countering that, but it becomes an art at that point of managing weld distortion to keep precision. But still, we want a nice tight tube fit up that's better for welding and all kinds of connections. We want a nice tight fit up, and with properly placed parts, we can get that, and we can cut independent parts properly so that they will fit up if our tooling is correct. So anyway, let's move away from this. Oh wait, I wanted to say, of course, we solve all this mathematically as well. Here are the various formulas for all these sorts of solutions. The math gets a little complex, but we're generally starting with fairly well-defined features within a bike. So we want to hold the tubes. Now, there's bad ways and good ways of doing that. Here's a post on the math. Probably what most people will reference as sort of the beginning of the new era of fixtures is the Arcbos. Basic 80-20 beam type of thing. And the Arcbos maintains a horizon that is true to the frame. And that's pretty useful in lots of ways because we can work from that and get expected results referenced within the frame. And, this is made by Simple now. It was originally made by Helfrich, I believe, back in the day. And it's a very simple, adequate type fixture. One of the big things you're looking for in a fixture, depending on how you construct, is maybe torch access. If you're working with an open flame, you might want to, or in a high production environment, you might want access from both sides of the fixture. And that's great, but it comes at a cost. If you notice, these beams are kind of hanging out in space. The seat tube sticks way up there, and it's also coming into the center line of the crank. This design obviously hasn't been modernized to conform with what we're doing nowadays with offset seat tubes. Let's see, this type of thing, where we have an offset seat tube. But it's a pretty good design. It's been copied a lot. It will get you a bicycle frame. You're depending on the connection that you've made in every place for your in-plane type of stuff. But this is fairly adjustable, and adjustability is fairly nice in a fixture. People talk a lot about perfection, but when it gets down to it, when you're welding the bike up or you're right there, sometimes you do fudge it a little bit, and it's nice to just kind of creep a dimension in the fixture back or forth to meet the realities of the situation. And one thing nice about this type of fixture is it can be, if you're going to make a change, you can shorten or lengthen the bike by 1 millimeter to make to save a tube set or something like that, or you miscut or overcut or something like that. And in general, 1 millimeter isn't going to matter. Certainly when it means maybe throwing away a few $100s worth of tubes or, a day's worth of cutting time, um, or expensive machine parts. Um, so you're going to want to be practical as well. And the nice thing about a fore and aft adjustment when you have a frame fixture is that you don't throw off any of the angles or real fit ups. I mean, yes, the cockpit may get 1 millimeter shorter, or the rear center might get 1 millimeter shorter, or something like that. But you're not really messing with how the bike steers or most of the other things, so it's fairly nice. Um, anyway, there's another type of fixture that Joe does over at Cobra, and this is a little bit different than the Arctos, and it's cool. It's efficient. It's very efficient and can probably add a bit of precision, um, where the main, by doing that, it makes it so that only one angular adjustment is made when you're setting up the bike. If you notice, Joe up here has a offset seat tube adjustment, which is very important in modern bike design. If you're going to do a mountain bike or a gravel bike, you need to have that. It's very limiting, and you end up making not very good bikes if you can't do an offset seat tube. Um, anyway, Joe's put a lot of work into this, and it's fairly refined at this point, which is nice. He's got some cool bearings that slide to prevent racking on the back of the fixture. I don't know if he has any better photos of it back here. But he also has accessory mounts and stuff like that. He's really taken it pretty far, and it's cool. But one of the problems with this design, while it's fairly efficient and it's currently available at a fairly good price, um, that moment I was talking about where you're about to weld things together and your tubes are just slightly short and you just want to choke them up a bit, it's not as easy on a fixture like this. Now, there's ways of doing that, of course, but they're a bit more complex than with a horizon type fixture where you can just choke it up a bit. Because you can very adverse, if you carelessly make changes to this fixture, you can very adversely affect what the end bike becomes. So it does get complex when that happens. And if you're an expert user at this fixture, that won't be that much of an issue. And that's pretty cool. Um, and yeah, and Joe makes them, whatever, buy them. Um, I worked at Fat City back in the day. That was end of the 80s, basically 90, 92-ish type of area. And I worked with Jeff Buckles. And he later went off to work with independent fabrication. And I went off to work as a professional machinist and uh, motorcycle race and car race stuff and everything like that. Um, but Jeff went on to at Fat City we had one of the huge Marchetti and Lang fixtures in the era that I was there. I wasn't there in the dinosaur era, but one of the huge Marchetti and Lang production fixtures and a steel plate fixture, which I can't remember offhand exactly what it looked like, but Jeff kind of got into tool making for independent fabrication, and he started making fixtures for independent, and then he went off and did his own thing, and that's Sputnik. And the Sputnik's a horizon fixture, and it's a bit more, it's a plate style horizon fixture, let's say a cutout plate style, where some provisions have been made to improve the clearance to get to the back sides of tubes. Generally, I think he's working with TIG welders, to do this, but I know there's some flame people using his fixture, and it's a gorgeous, gorgeous fixture. You know, it's very easy to make very specific adjustments to the head tube. Everything's on bearings. It's very kind of tool room grade in terms of how it's done. He also, unlike this photograph, I believe Jeff also has an offset. Oh, there we go. He has an offset um, provision at the top of the seat tube area so that that can be done. Oh, okay, so Jeff's is a very, very high quality fixture, a lot of steel and solid aluminum being used in there. Generally, people that are really in the pro level of building or want pro level tooling will be looking at this kind of thing because it's designed for the person that works with it all day type of thing. Well, then we get to what most people know is the Anvil. This is the 3.1 Journeyman. This is on Anvil's old um, Flickr site. Um, I pulled up an animation that Anvil, um, what's his name? Let me drag this from over here. Oh no. Nope. 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 Anyway, I had a video and I screwed that up. That Don's son uh, made of the fixture working, where it was the earlier swing style, where there was an angle off the bottom bracket for the rear axle to be placed. I had one of those fixtures. It was terrible. It was absolutely brutal to use and trust. And that's a thing we're looking for in a frame fixture. We want to trust it. We want to believe that if it says so, it's right. And not that these were inaccurate in any way, but the things that can go wrong, or if you make a mistake, or if something's off slightly, what are the downstream consequences? And just like when we talk about like Joe's fixture, that there's unexpected consequences to one adjustment, if that angle is slightly off, it really screws everything up. And it was very hard to adjust in my mind. This is the newer style. I also had one of these. A lot easier to use than that first one. Um, and of course, this is another plate style fixture with a lot more cutting out being done. Um, and it was it was cheaper than some of than maybe the Sputnik. The problems were solved in a bit of a different way. One of the really cool things about Sputniks, especially for this, is right here we have a provision so that you drop a pin out of that head tube area, and the bike, you don't have to ever mess with the head tube positioning if you're taking a bike in or out, or if you're doing a run of 30 bikes. Every bike's going to be in dead nuts the same position, which is really cool. Now that wasn't a thing on the Anvils. Releasing the bike from the fixture was generally a real pain in the ass, in my opinion. There's a lot of racking in the way the slides work. It's not that it won't work well. It was kind of pesky at times, but they were very good, and Don really did a good job supporting all of his tools, and he had an ecosystem that you could work with. That and while Don stopped building bikes years ago, his dropout dummy axles, the spacing on those has become essentially the standard. Um, they have a bit of a problem in that they aren't, what's it called? Anyway, kinematically constrained very well in terms of there's ambiguity in the placement of that axle. And we've had a few issues with that in all sorts of fixtures. Um, Back in the day, I did that offset post type of thing. Here's a prototype type thing where made an offset, and this is the one Don made for me, the first one of those that solved that problem, and it was very nice. I was pretty stoked on that. And now we have a really nice way of defining that type of thing. So you can see there, I mean, there are other fixtures, but these are the main ones that we kind of really need to talk about. I do see a lot of people copying some pretty bad designs out on the internet, and I know this isn't a fully in-depth or as in-depth about everything, but um, we want to start talking about better fixturing, better methodologies for particular ways of doing things, not just that somebody did it in the past. Like, I pity some people that have certain tooling that was sold and produced, and some tooling that people talk about or even sell currently that are just very bad tools. And there, that's the thing. We need to recognize good tools, not and disregard bad tools. We need to look out for what's being done. But I would say, these are probably the big ones. The the Arctos, the Creator, the Sputnik, and the Anvil. That's what most people are going to encounter or reference or have around. Um, okay, there you go. Oh, also, you know, we have to define the bike, and in a way, this is me trying to figure out what are the definitional parameters that we're going to use when setting a fixture, right? It's like you can set a fixture in many ways, but there's once you start designing a fixture, you start seeing that certain things can't work, like um, top tube length or stack and reach type of things aren't very good ways of looking at bikes. Actually, they're terrible ways of looking at bikes, but they really fall apart once you start trying to build bikes using those methodologies. And here we get into front center and rear center as primary driving parameters. Um, and you can see that if we go back here, I've got my on this bike, that front center of 830, rear center there, the bottom bracket height, the various wheel diameters, the handlebar position. I need to have 240 stroke clearance, and that's why we push our bends down as low as they can. This is just drawn that way because of bike CAD. It actually intersects that tube for even more clearance. Um, yeah. Okay, so I'm gonna shut this down and we'll talk about other frame jigs later.